Alright, let's look at the homework 11.3, problem number 9. Alright, so we have a p-series here with p equals 4, and the part A, use the sum of the first 10 terms to estimate the sum of the given series. Alright, so let's do that. Alright, so all you have to do is just find the S10. So part A, we just have to find the S10. Alright, so this goes 1 over 1 to the 4th plus 1 over 2 to the 4th, and you keep on going until you hit 1 over 10 to the 4th. Alright, so let's compute this using Geogebra. Alright, I open up a Geogebra. There's a function called the sum, so I'm going to just go ahead and use that. And the sum, alright, then here's the second one. Alright, I'm going to put in the expression, so it's going to be 1 over n to the 4th power. And the variable in this case is n, and it's going to start from 1, and the n value is 10, because since it's a S10, and hit enter. Alright, it gives you actually a fraction value here, so I'm going to do, I want the decimal point, so numeric is the next, then you can just click on here. Right, so it gives you a decimal value there. Right, actually I'm gonna have to change it to 10 decimal places. All right, so this came out to be 1.082037. All right, so let's type it in. All right, so the value was 1.082037. Right, so let's go ahead and submit for testing. Okay, looks like we got part A correctly. Right, so let's do part B. Improve this estimate using the following inequalities with n equals 10. Alright, so we're talking about the lower bound and the upper bound of the sum s. Alright, so let's compute those values. Alright, so part B. So lower bound, so I'm going to call it L sub 10. Alright, this is going to be S10, which we already found, plus, right, integral, right, n plus 1. So in this case, n is 10, so 11, and to infinity, right, then you have 1 over, right, x to the 4th dx. Right, so let's evaluate this integral here. So maybe I'll do it on the side here. All right, so you have improper integral, so 11 is okay, but I have to replace infinity by t. Then we have to take the limit as t approaches infinity. Right, and 1 over x to the 4th, I like to write it as x to the negative 4 power, so that we can easily apply power rule. Alright, so this is going to be equal to limit as t approaches infinity. Alright, so antiderivative of x to the negative 4th would be x to the add 1 to negative 4 would be negative 3. Then you would have to divide by negative 3. Then you're going from 11 to t. Alright, so we can rewrite this guy as, right, so it's going to be definitely negative, and 1 over, looks like a 3 is on the bottom, right, then you have x cubed on the bottom as well. Alright, so plug it in, so you're going to get the limit. We have to take care of this limit later. Alright, plug in t, so you're going to get negative 1 over 3t cubed, alright, minus, right, negative, so it's going to be minus minus, so positive, right? So it's going to be 1 over, right, 3 times, right, 11 cubed, right? So we have that, right? And as t approaches infinity, you can see that this quantity right here, since only the denominator goes to infinity, 1 divided by a big number, it's going to approach 0. All right, so we have, this is going to be simply, that's 0, so it's going to be whatever this value is, 1 over 3 times 11 cubed. All right, so let's find this decimal value using GeoGebra here. All right, so I'm going to bring the GeoGebra here. All right, so first thing is we have S10 is already here. So I'm going to use that. And so I'm going to just click here. All right, this is S10. All right, oh, I did something here I don't want to do. I'm going to delete it. All right, then I'm going to add. All right, so actually here. I delete the one I needed. All right, so I'm going to delete this one. And all right, I'm going to actually just, all right, I'm just going to write on this. All right, so I'm going to click on this. So we got that value. All right, then we're going to add, so that's S10. And I'm going to add 1 over, all right, 3 times 11 cubed. All right, then I'm going to hit enter. All right, again, I have to get a decimal value. So numeric, all right, so numeric, then I'm going to put that value there and hit enter. All right, so we got this value, 1.082287. All right, so let's type it in. All right, so the lower bound we found was 1.082287. Right? So let's find this value first. Actually, check the answer first. All right, so looks like that we got the lower bound correctly. All right, let's find the upper bound. All right, upper bound, so I'm going to call it U10, is going to be S10 plus integral from 10 to infinity. All right, and 1 over x to the 4th dx. All right, so let's compute that, and you can see that the only difference, we can actually guess. All right, so when it starts from 11, it's 1 over 3, then 11 cubed. So it's obvious that when you start from 10, it's going to be 1 over 3 times 10 cubed. All right, so let's compute that value. All right, bring out the GeoGebra here. All right, so we have, so I guess I'm going to go ahead and do numeric. All right, numeric. All right, then we put S10, which is that value. Then I'm going to add 1 over, all right, 3 times 10 cubed. All right, hit enter. All right, so we get the 1.082370. All right, so let's type it in. All right. All right, the upper bound we got was 1.0823 and 70. All right. So let's check the answer. Submit for testing. Okay, looks like we got part B correctly. All right, so let's look at the part C. All right, it says that use the remainder estimate for the integral test. Find the value of n that will ensure that the error in the approximation s equals s approximated by Sn is less than 0.00001. All right, so let's do that. All right, so part C. All right, so we are looking at the error. right? Error is simply difference between the actual sum s and then estimate s sub n, right? And remember that this is always less than or equal to integral from n to infinity, and then you have a function 1 over x to the fourth with respect to x, right? So you can see that this is going to be, right? So we can just use the same trick. It's going to be 1 over, right, 3 times n cubed, right? Because when it was 11, it's you get the 1 over 3 11 cubed. When a lower limit is 10, it was 1 over 3 10 cubed. So this is going to be that. And then we want to make sure that this limit is going to be less than 0.00001. All right, let's solve for n here. All right, first thing is I'm going to take the reciprocal of both sides. You get the 3n cubed, right? Then reciprocal of that would be 1, and you have to have 5 zeros, right? So when you take the reciprocal, we have to change the direction of the inequality, right? Then we're going to divide through by 3. So you have n cubed is greater than, it's 100,000 over 3, right? Then we can just take the cube root of both sides. So n is going to be larger than cube root of 100,000 divided by 3, right? So let's compute this value using Geogebra here, right? So we just need to find, let's see, we need to find 100,000 divided by 3, and then I'm going to just raise it to the 1/3 power, right? So I hit enter, right? So it came about the 30.18. So what we can do is we can just put the 32. So this should be the answer here, right? Let's check the answer. Submit for testing. All right, it came back, and we got part C correctly. All right, that's it. I hope that this was clear.